Hello, everyone, and welcome to week 13 office hours, the final office hours I'll be doing for this class, and hopefully just checking, waiting for the stream to start up. Looks like it's good. Yep, okay, good. So, so this is it. This is the end of our journey. Hopefully it's been fun. Hopefully you learned something. Hope you. Let's see, is it? I'm gonna read. Hello, hello, hello. Testing, testing, testing. Okay, so it appears we had a few issues with starting up the live stream this morning. Sorry for that, but I'll start again. Hello everyone, and welcome to week 13, the office hours, the final office hours where I'll be coming to you. Hopefully, this has been a pleasant and enjoyable and educational experience for you. That you've learned a lot about agent-based modeling. That you've hopefully developed your own model that you can take away and use and kind of look back upon. And as I mentioned in the last couple of emails, last couple of office hours, if you do decide to post it publicly somewhere like Open ABM or Net Logo Modeling Commons or someplace like that, please let us know and send us a URL. Often we like to collect those URLs and then put together kind of a little newsletter afterwards. So let me know if you do in fact wind up doing that, okay? So a couple other quick notes just as we're wrapping up. So, officially you have until, I believe it's next Tuesday, but I'm going to double check that real quick. You have until October 9th. Oh, so that is Sunday, right? Isn't it? Oh, sorry. Well, that is next Tuesday. Wow, I was right on the money and didn't even know. So I'm miscounting days in my head. So October 9th, which is next Tuesday at midnight on the on the West Coast, right? Or that is also that's also 3 in the morning on the East Coast, right? It is 3 in the morning on the East Coast or 9 in the morning on Wednesday, October 10th in Europe. Okay. Anyway, so you have until then to finish up exams, right? At this point, it's too late to kind of turn in the models or turn in peer reviews or anything like that, but you have until then to finish up any of the exams you haven't done. That's basically it. There's also one other thing I really would ask you to do this week, and that is to kind of fill out the surveys. And I hate to ask you to overburden you with 3 surveys, but none of them take very long. They're all fairly quick. And they're in the email I sent you earlier. And so one is the Complexity Explorer survey. So this is done the same for all the courses, and it's just kind of a way to compare and contrast the courses and decide what new course offerings to make, how well each course is doing, etc. So I ask that you do that, so Complexity Explorer. Then there's the survey that I sent you out that basically is specifically to get feedback on how we can improve this course, right? How can we make this course better, right? And so that's in there as well. And then finally, there is a link in the email I sent to something called ClassCentral.com. And Class Central, you can think of it as kind of like the MOOC. You can think of it kind of like the Yelp for MOOCs. I almost said that backwards, right? And I highly recommend going on there, doing a review. It helps other people find this course, right? So if you want to help other students find agent-based modeling classes, then leave us a good review on there. 5 stars always better. Nah, just whatever. That's what I feel like we hear all the time now, don't we, on these podcasts and apps and everything. But leave us an honest review. Honestly, tell us the truth, right? Tell us how you're doing, and it'll help other students find out. And we'll just leave it at that. So leave us a good review there. So all 3 of those links are in the email I sent out earlier this week. If you have troubles with any of those, let me know, and we'll help you out. Okay. One other thing, obviously, you should be getting your certificates as you finish up the course. If you have trouble getting your certificate, please let me know, right? And we'll see about getting into it. Okay. So that's all the big administrative items I had. For some reason I'm buffering quite a bit today, it looks like. I will try and shut some stuff down on my end. I don't know if that's what's causing it, and hopefully maybe it'll improve. Might be Skype. What do I got running here that's causing troubles? Okay. So let's see if we get that all shut down, if the buffering issue goes away. Okay. I don't know how this is up. Okay. So that's all the big administrative items I have for you today. If you have any questions, feel free to shoot them. You can post them directly on the chat. You can also tweet at intro to ABM, and I'll check for them there as well. Those are the best ways to get a hold of me. By the way, if as you're going through the class and you're and you're done with the class and you move on, and you want to provide me some feedback, stuff like that, feel free to email abm@complexityexplorer.org. I should say don't email that if you have an emergency issue, like you're trying to get your certificate a month after the class ends, because we don't tend to check it that much that late. If that's the case, if you have something with the certificate or something like that, I would email admin@complexityexplorer.org. But please, please, please keep me up to date as to how the stuff that you've done with the course, any feedback you might have, any questions you might have about agent-based modeling. Feel free to reach out to me. Once the course is over, you can always reach out to me. My personal Twitter handle is @BillRand, very easy to find. And you can email me at wmrand@ncsu.edu, right? Those are the best ways to get a hold of me once the course is over. But feel free to shoot me any questions you have about agent-based modeling at that point. Okay. Thanks everybody for being in the course, and let's get to the questions. Okay. So a couple questions came up in the forum. So Mohammed asked if agent-based modelings have to be stochastic. And I would say no, they don't, right? And it kind of depends upon what you mean by stochastic, right? So for instance, there are certain models that are completely deterministic yet have interesting dynamics. So let me talk about one. So there's something called the Sampaio model, right? And the Sampaio model is kind of an agent-based model. You can also do it using non-agent-based modeling, right? But it still has interesting behavior. I would also, and Chanika posted a response where he said ABMs are typically stochastic, right? But they're not necessarily stochastic, right? And I definitely agree with that, right? A lot of times, I think stochastic behavior stochastic behavior in many cases is done for a number of reasons. One is because there might be something that's happening at a lower level that we don't want to completely model, but we can model as a stochastic process and still have the same results, right? So I'm trying to think of a good example of this, right? So grass regrowth, right, in the wolf sheep model. In the wolf sheep model, grass regrowth, right, sometimes is done as a stochastic process where, with a certain probability the grass regrows, right? What that's supposed to approximate is the fact that every single patch of grass, right, has some small probability of regrowth, but really it probably is a fairly deterministic process. It's probably determined by the amount of sun it gets, the amount of water it gets, the amount of other things it gets. But we don't want to model all that, right? So at some level we draw a line and we say that at this level we're just going to model it stochastically, right? The other reason why stochasticity is often used in agent-based modeling is that we don't want to make any strong assumptions about the way the system is set up, right? So if, for instance, let's say that every time we create our agents, that ask agents went through them in the order in which they were created and had them execute, right? Well, that's a very specific view of the world, right? That's saying that agent 1 acts first, then agent 2, then agent 3, right? By having ask work randomly every single time, we're kind of shuffling that pattern, and we're kind of destroying that dependence on that assumption that the agents will work in that exact way. Now, we are making another assumption. We're making an assumption that they'll act randomly, and if, in fact, they do act it was originally suggested by Per Bach, and it's been implemented in NetLogo as a agent-based model, and you can think of it as an agent-based model. Remember, agent-based modeling, in my mind and many people's minds, is more of a way of viewing the model than it is a particular quality of the model, right? And so as a result, but you could build the Sampaio model through other ways, is what I'm trying to say. I just think it's the most natural representation in my mind is as an agent-based model. Okay. Oh, okay. Trying to make sure I have it set up and running properly. Okay. Oh, and still, they have some stochasticity in this version of it. So unfortunately, it's not going to be as non-stochastic as I'd like. But I'll give you an idea of what I mean. Let me see. I could actually, I may be able to actually modify it quickly and make it not stochastic. So let's go. Merge drop. Patches on. So let me describe the Sampaio model while I'm doing this, right? So the Sampaio model, the way it works is that you imagine a world that's full of sand, right? And every time in the world, a sand grain is dropped on top of the world, right? And that sand grain, let me make this screen bigger too. Oh, not move mine around. Let's make this screen bigger. Okay. Every time that grain is dropped, it slowly builds up a sand pile. But obviously, grains of sand can only stack so high, right? They can only get so high. And then they're going to spill over, right? And anyone who's ever had this experience at a actual beach knows this, right? You build sand up, and it slowly moves, and build sand up, and it comes down, right? So what Per Bach said, well, let's build a formal model of this. So imagine I drop a grain of sand, I drop it down, and as soon as at least 4 grains of sand build up, the sand pile disintegrates, right? And so I distribute each of those 4 grains to the 4 neighbors of it, right? And I keep doing this. And what he showed is that model has this interesting pattern of behavior, right? So he calls that an avalanche once it collapses, right? And he showed some very interesting relationships that essentially, if you drop these grains down kind of randomly, you eventually get to a state of the world where the size of the avalanches, the number of subsequent avalanches, they call it, the number of grains. And then, of course, remember, like if I cause an avalanche here and there's 3 grains of sand in every corner around me, that's going to cause 4 more avalanches, right? It's going to cause more avalanches. So the size, the total amount of avalanches that happen as a drop of resulting 1 grain of sand over time creates a power law distribution, right? And so he had all these kind of cool. He called this self-organized criticality, right? That the system evolves naturally to the state. The point I want to make is that you don't have to have all that stochasticity to actually get that system evolved. It turns out if instead I just have a blank canvas of sand and I just start dropping grains of sand down in the middle every single time, I still get this power law type of behavior, right? What's powerful about Per Bach's finding, right, is that happens in stochastic or non-stochastic worlds, essentially, right? And so that's kind of intriguing from that finding. So in the model, which I'm about to show you, right, essentially the way it works, and unfortunately I don't have the version where it's non-stochastic, I don't think, but you have this kind of uniform background. So we're looking down on the sand pile from the top, and then we're going to drop 1 grain of sand. So we drop 1 grain of sand. You might not be able to see it, but it's down here in this corner, right? And then if I keep dropping the sand, right, and let me go, right, eventually I'm going to get to a state where there's going to start being some avalanches. And already you can see there's one that's a little bit brighter in the bottom left. That's because it now has like 2 grains of sand piled up. But this takes a little while relationship, right? If instead of, oh, here it is. Here's the selection I wanted. If instead of doing it stochastically, I do it uniformly, right? So now I'm always dropping the sand at the same spot at the beginning, right? Then I still get this nice power law relationship. And in fact, it happens faster because all the activity is kind of classified in the middle, right? So yeah, so to answer your question, Mohammed, basically, in the end, agent-based models don't have to be stochastic, but it typically is a good proxy for what we're actually doing and is a little bit more robust, right? I don't find, like, I don't know if someone, like, this is beautiful, this model, right? But if someone had shown this to me and said, oh, this is a really interesting behavior, I would have been like, oh, it must be because you're dropping it on this one patch, right? If instead someone says, oh, I'm going to set up the world completely randomly and drop the patches randomly, and I still get this power law behavior, right? No matter how I do it, no matter where the patches come down, I don't know. To me, that sounds a little more interesting. But that's my personal thoughts on it. Okay. So we had another question, and let me turn off the view. And this is from also from Mohammed, who wants to know if it makes sense to make an agent that's actually 2 or 3 agents. So this is actually a typical question that comes up, and we talk about it quite a bit in the book if you want to buy the book. Often you want to scale your agents. So if you look at, for instance, the ticket sales model, so let me pull that up again. Right, so this is a model, actually, if you remember correctly, I talked a little bit about this last week. This model actually brings in real census data to populate the agent space, right? But it doesn't populate at a 1-to-1 ratio. If you look right here, right, in this piece of code, right, it specifically says that it's actually going to it's going to create a number of turtles. It's going to create 1 household for every 100 households in the real world. And the reason why was because we found when building this model, right, that we didn't really need a 1-to-1 map, right? We could get a pretty good mapping with having just 1 agent represent 100 agents. And so it really depends upon what question you're asking and what question is important for you, right? There's also another idea, by the way, of having oh, I'm sorry. I'm answering Mohammed's question wrong. I thought he said if you represent 1 agent with 2 or 3, or represent 2 or 3 agents in 1. But really, what he was saying, what happens if you build a model with just 2 or 3 agents? And so that's a different question, right? So scaling we answered, right? So scaling we answered. So it is sometimes very useful to scale up your population. So let's go the other way, right? What if I only have 3 agents in the world that I'm interested in, right? Is that all useful to build an agent-based model? Well, this again becomes a question of trade-offs to some extent. And I have actually seen agent-based models with 3 people. For instance, Joanna Bryson, who's at Bath, used to do some really cool work in NetLogo building models of just like 3, maybe 4 or 5 primates, right? So monkeys and apes and things like that. And she would build models of their cognitive behavior and how they interacted, right? And I think it was mainly apes, in this case, but I could be wrong. And so each ape actually had a full cognitive system to it. Like it was making decisions about whether it was hungry, whether it needed to sleep, whether it needed its back scratched, whether the flies were bothering it, all these kind of things, right? Well, it turns out, that was really interesting, but she really only needed to have like as many apes as would be in a particular troop at the time, right? And so she didn't need 100 agents, right? I think she had like 5 or 6, but still, right? And so in that particular case, you see there's a trade-off there. She's trading off quantity of agents with depth of agents, right? So she's taking away some of the breadth of having many, many agents in her model and trading it for depth, having very deep agents in her system. And that's a common trade-off that we actually face. And so that can still be useful. And if you remember back to like one of our very first lectures, we also talked about that one of the hallmarks of agent-based modeling is median numbers, right? So, and I described those as hallmarks. And the reason why I describe them as hallmarks is because just because you want to model a system that has only 2 or 3 agents, and in Dr. Bryson's case, she did want to model just 2 or 3 agents, right? But they had very complex interactions, right? And that was very interesting for her, right? And so it still made sense to use agent-based modeling because it was a good way of representing what was going on, right? However, often it's the case that you look at systems that have on the order more of 100 agents, right? Because that's where agent-based modeling really starts to shine, right? Some people might argue that when you have a smaller number of agents, right, that's things like game theory or or qualitative methods might provide you with a better description of the system. So it becomes a little harder, but you have to think about that and think about, why am I using agent-based modeling for this 2 or 3 agents, right? I'm not saying you shouldn't do it, but you should at least consider why you're doing it. Jack asked if it's necessary to finish all the models by the 10th in order to finish the course. Jack, my understanding is that the course finishes on the 10th of October. You don't have to, if you want to get the certificate, yes, you do have to finish all the exams at least by the 10th and achieve a score of 70% in order to get the certificate. However, the materials will be freely available after the course ends, right? So there's no reason, if you're just doing this to learn about it, right, then that's fine. Also, if you want to get the certificate, but don't feel like you have the time to watch all the videos, you can always try and take the quizzes, see if you're doing well on the quizzes, and if you're doing well on the quizzes, take the test and just do the test before watching all the videos, right? Like I quite frankly, I want you to do what you need to do, right? And at times that means if you can pass the test without watching me talk for a couple hours, then go ahead and pass the test, okay? I had a couple questions that came in my email. First of all, I want to thank Jonas and Adam for sending their models to Open ABM and sending us the links to them. So we'll definitely put those in. We'll keep track of those. Thanks for your work there. Then Cal had a question on mathematical proofs. He's developing an agent-based model and using it for image compression. Sounds very interesting. Do I need to have a mathematical proof for such a system? Is it common in agent-based modeling? I actually, no. Mathematical proofs are not the ultimate example of verification, right? Like if I can prove that my system will always produce the results I say, right, that would be the ultimate proof. But often if we're producing a formal proof, an agent-based model is not really what we would want, right? We just use the mathematical model to begin with, or the logical model to begin with. So I would argue that most times agent-based modeling is a formal proof is actually not something that's typically done, and usually it's very, very hard to do, right? Even in most software engineering cases, right, for non-agent-based models, right, other software pieces, it is very, very rare to do a formal proof for verification, right, because that would be, because it's just not tractable for the amount of code that you're looking at. But your paper sounds really interesting, Kyle. I'll definitely take a look at this, right? A novel agent-based modeling approach for image coding and lossless compression based on the Wolfsheet predation model. Very interesting to me. I'll definitely have to take a look at that. That sounds fascinating. Yeah, okay, cool. So Momona has a question that they specifically sent us for office hours. I want to be guided to write codes for following. Let's say that there are farmers and I want 75% of them to grow crop now and the rest to crop later. If the farmers use groundwater 75% of the time and surface water the rest of the time, and if farmers use 75% of the time groundwater first, 25% of the time surface water in the last stage of cropping. Huh. Okay, I'll see if I can do this. I mean, I think I understand kind of what you're trying to say. Okay. I'm going to pull up my NetLoader window here. So we have some farmers. And let's imagine that we have let's imagine that we have 100 farmers. Okay, we'll set their shape to be person, I guess. Set their color to be white. Set their XY to random X core, random Y core, right? Okay. Actually, yeah. Set not sexy, set XY. Okay, so we're gonna create a button for setup and a button for go. And move that for a button, of course. Right? So let's see. So if I think this through a little bit, kind of what I think Moana is asking is that basically, let's imagine a world in which there's where they each have their own crops, right? And their crops are their patches. So let's not allow them to be on the same patch as another. So if any farmers here set XY random X. Oh, actually, I did that a little bit wrong. While any farmers, and then that's going to be into the brackets. Okay, so if it's set up. Oh. Well, any other farmers here, because there we go. Okay, so now they're all on their own patch, right? And so she wants them to kind of plant. Let's say it's plant, water, harvest, plant, water, harvest, plant, water, harvest, right? It's kind of the cycle. I don't know if that is, but I'm guessing, right? So we can have a status of what they're currently doing, right? Plant, water, harvest, right? And set plant. Oh, don't want to put this here. Set plant to false. Set water to false. Set harvest to false. Right. So now each time we're going to have them just iterate through the ticks. Right. So the first thing we got to do is, according to the question, is that let's say the farmer's 75% of the crop now and the rest of the crop later. So what we can do, right, is in the initial tick, right, ask 0.75 times count farmers, ask n of, times count farmers, to set plant true. Right. And what we'll do is just to kind of make this so usually it's useful to start up the world in a state where you can continue to run the world, right? And right now they're all set to false. So we'll set the other ones to harvest because it's like they just harvested just before the world's ended, or they're harvesting when the world's starting. Sorry, world's the world's starting. Ask farmers with plant, with not plant. Set harvest to true. Right? Okay. So there you go. So that should work to set up the world. So that's the first condition you're talking about. And now I'm just going to kind of fix the rest, right? So I'm going to get the rest of this started running up. So basically, ask farmers at the beginning of each tick, if plant is true, right, then set plant false and set water true. Right? So basically, if you just planted, now we're going to water. If water is true, right? Set water false, and then set harvest true, right? And if you just harvested, right, set water, set harvest false, set plants true. So basically, this is a common way. If you have like a set of agents who are moving through stages, right, then at the very beginning of each tick, you just move them through each of the stages, right? And this would be a standard way to do it in this thing. You can do it more complicated by doing some lists and stuff like that, but like if you have just kind of a kind of small number of stages, then this works pretty well. Okay. Now, what I can do next, so now I have them cycling through, and let's just check to make sure that I wrote all this code. Ask farmers, not farmers question. Let's make sure I wrote this code correctly. So the way we're going to do that, we're going to create a couple of monitors, right? So farmers with plant, count farmers with plant, planting. Count farmers with water, watering. Count farmers with harvesting. What's wrong with this one? What did I do wrong? Count farmers. Oh, I keep doing that. I don't know why I keep adding this one. Okay. Setup. And as you can see, we did it correctly. 75 of them are planting and 25 of them are harvesting. Oh, I need to reset ticks. That's what the command was. I was trying to remember. I was like, I think I forgot something I did after this. Reset ticks. Okay. Oh, I did something wrong there. How are they all planting now? Am I screwing up? Set waterfall. No, it must just. So this can sometimes happen because monitors check constantly, right? So if you switch to the views as being only on the ticks, yes. Let me see this. Sounds like screws going on here. Count farmers with plant. Let's see. Count farmers with 100. What did I do wrong here? Let's see. So set plant false, set water true. Plant with water text. Somehow I feel like everyone's just moving into plant and staying there. Oh, I got it. This is kind of a silly mistake, right? Because basically what I'm doing is I'm setting plant water to true here, which is then automatically causing this to happen, which is automatically setting harvest to true, which is automatically causing this to happen, which is making this happen, right? So the way you do this, right, is you break this up, right, into. No. The easiest way to do it, you need to know what the state was last time. So what you do is you say ask farmers, let old plants be plant. So basically, I'm going to copy in the status from the last time into a set of variables, and then I'm going to check those to update my new variables. So this is the kind of, like, if you remember from some of the stuff we did with the cellular automata where we cached values, right, and then got rid of them, right? So basically, we don't want it to make the decision about how to migrate based on current value. You want to make it based upon the way it was in the last turn, right? So now, if we hit setup and hit go, there we go. So it should work that at each time tick, right, we have 25 in each of these. Right, yeah. So they're just cycling through the harvest cycle. Okay. So now the last question, the kind of following question that Manana had was, she wants them to use groundwater 75% of the time and 25% of the time use surface water, right? I'm not sure exactly what that it means, right? But we could obviously have in a bunch of code that says ask farmers with water, right? And having them right in the action, right? So ask farmers with plant, right? And ask farmers with harvest. Right, okay. And then you just need to write your next functions to water and to plant and to harvest, and right. Let me scroll that up so you can see it better. Okay. And so what we can say, like, let's imagine we have some like a global which is surface water, groundwater, right? And let's imagine groundwater. Actually, let's imagine there is no surface water, because surface water, when it's available, is unlimited, but groundwater, right, is limited, right? So we can set groundwater 100, right? And then we can say, if random 100 is less than 75, right? And then what was it? 75% use groundwater, right? So then we're obviously going to take some water from the groundwater, so we're going to set groundwater to groundwater -1. If groundwater is greater than 0. And we'll do this just as an if-else to make it easy on ourselves, right? And I won't write any code for this, but basically this means use surface water, right? And we can figure out what that means instead, okay? So there you go. That should do what you're asking for, Manon, most of what you're doing. I don't quite understand. You have something about initial stage of production and last stage of cropping. I'm sorry, I'm not a farmer, so I don't quite know what all that means. But hopefully this gives you a place to start from, right? And an example of what you could do, right? Let me know if you have any additional questions. But this is, I should mention, I think this is an interesting question. This is kind of a common thing you often do in some agent-based models is you have like phases, right? Like I've often written code where, and I think we've shown some of this code in this class, right? Where like, you have a driver and they go to work and they go back from work, and they go to work and they go back from work, right? Oh, did I just lose the stream? It just hiccup that means. Sometimes that means I lost the stream. So those are kind of standard kind of things that you'll see sometimes. Anyway, so that's the last question I have for today. Myra has a comment. She says, excellent course. Thanks for all the knowledge, tools, and opportunity to meet other people with great ideas. Thank you, Myra, for being part of the course. Honestly, the class wouldn't exist without all of you. And so I really appreciate all of what you've done. And thank you for the work that you've put in. And I look forward to seeing these models in more depth. So just to recap from the beginning, right? Like you have until next Tuesday night basically to finish up all the exams to get your certificate. If you have any troubles getting your certificate, let us know, right? The other thing I would say is that if you get a chance, please complete the 3 surveys that we sent out, right? Including including the one from Complexity Explorer, the one from myself that basically allows us to modify the course, and then the one, and then if you get a chance, write a review for us on Class Central. And Sophia just wrote and said, thank you for your time. Thank you, Sophia. Like, as I said, we would not be able to do this course without you, the students. Thank you so much for all your efforts and responsibilities. If you have any questions after the course ends and you need to get a hold of me, you can always tweet at me at Bill Rand. I also try and monitor at Intro to ABM. And you can email me at either abm@complexityexplorer.org or wmrand@ncsu.edu. Thank you so much, everybody, for being a part of this course. And I hope the last week goes great. Take care. Bye.